Okay, so these next two videos, part 1 and part 2, I want to show you how you can identify a site using Google Earth and QGIS, and then how you can capture information from Google Earth and use that in QGIS to create a land use layer. And in this particular example, I thought it might be nice to see what the Gigafactory in Berlin looks like and the impact on the plantations in the area. So I mean, these are not natural forests by the looks of things. These are plantations, and how many trees were removed, let's say, from this particular site. So what I did is I located it in Google Earth. I then used the OpenStreetMap imagery to capture the extent of the Gigafactory. Now, I don't have the actual site plans or the layout of Gigafactory, so I'm going on OpenStreetMap imagery and assume that this is the actual footprint. So this may not necessarily be 100% accurate, but it does give you an idea of how to use the modeler, which I ultimately want to show you, the graphical modeler of QGIS. So the next thing I did in part 1 was I did the land use. I then created a random point file for the trees. So I needed to have a layer that I could compare to underlying features, and I didn't have a point file layer for the trees. So that's why I needed this random point file, which was created using the forestry area and the plantation density of 2,300 trees per hectare. And then once I had that, I moved off into part 2 of the tutorials or the videos, where I actually show you how to use the graphical modeler or the graphics modeler. And that was to determine the number of trees in a particular area with a differing buffer. So the modeler allows you to choose a different buffer distance and then outputs the number of trees in that particular area. So I then captured an extent and then a footprint for the actual building site, and then ultimately by running this modeler I was able to quickly run through, create a buffer for extracted features, and then count the trees and export a particular result with a particular style and come out with this. So for instance, on just the footprint with no buffer, there are 49,259 trees from the random point file. So yeah, follow on, and if you're interested, see how I do that. Part 1 and part 2 are slightly different, but part 2 is when I get into the graphical modeler. So if you are interested in that, you can skip straight forward to part 2. Okay, so I want to start off by locating the Gigafactory in Berlin, and I'm going to use Google Earth to do that. So let's open Google Earth, and in the search function I'm going to type in Gigafactory. Gigafactory Berlin, and then click on search, and it gives us a couple options, but the one we want is this version here, A. So Gigafactory Berlin, and that takes us or navigates us back to Berlin. We can close that down, so let's just minimize that option, and I'm just going to zoom out slightly, and this is where Google Earth says the Gigafactory is. This imagery, the imagery date is 2018, so June 2018. So clearly nothing has happened yet. And if we have a look at the historical imagery, they don't have anything later than that. So they're either conveniently hiding it, or they just don't have satellite imagery for this section of Berlin yet. So anyway, we can get rid of that historical imagery. And what I want to do is I want to locate this in QGIS. So I'm going to create a placemark. I'll just call it Giga. And okay, it's just a point. And maybe just move it slightly. I can move it just by opening up properties and dragging it to the right place, or where I think it should be. And then I'm going to export this placemark as a KML. So save placemark as. And I've created a Gigafactory data folder for myself. So I'm going to save it in there. Giga KML is correct. And that is it. We are done with Google Earth. So I can close that down and open up QGIS. And then what I have done also is created a shortcut under favorites to that Gigafactory folder, which is sitting on my desktop. And I'll just refresh this. And then I should now have that Giga KML, which is in that folder. So let's drag that across. and drop it in our map view. It's the only thing there. What we can do is turn on the quick map services to see if it's in the right place. So I'm going to turn on the Google satellite imagery, which should be the same stuff. It should be 2018 June 6th, and I just need to zoom out by the looks of things. Okay, there we go. Lots of forests. Okay, so that looks like we're in the same place. It looks a bit distorted because we've got a different coordinate reference system. I'm going to change this to the same coordinate reference system that Google Earth uses, which I think is pseudo-Mercator EPSG 3857. If I say OK, that should transform to look something similar to what it was in Google Earth Pro. Okay, there we go. So I don't need that KML anymore because I am in the right place. Alright. So the next thing I want to do is add some information. I want to capture the land use layers. And I want to do that because I want to create a random point file. I'm going to generate a random point file for all of these trees. Because ultimately I'm looking to calculate how many trees fall within the various footprints of the building that they are constructing. If we just quickly have a look at the open source imagery, I think that actually it does have the footprint for the Gigafactory. There we go. So I want to be able to create a random point file for all of the trees, and then I'm going to capture the extent of the Gigafactory and then calculate how many trees fall within those various extents. So that's what I'm going to do next. Alright, so I've thought about this, and I think the best way to do it is to create a new shapefile. I'm going to make it a polygon. I'll put it in my folder with my other information. Let's just call this circle, which is not very original, but it describes what I'm about to create. And it does, yeah, we can create a field for it, but I don't think it's going to be necessary. So let's just say OK, and then what I'm going to do is start editing. But before I do that, I just want to set the style for this layer, and to make this actually slightly opaque. So let's just change the layer rendering to 50, and then maybe make this like a bottle green, something like that. Great, okay. Then the next thing I'm going to use is a toolbar over here, which is called Shape Digitizing Toolbar. So if you right click on your toolbar, you can turn on Shape Digitizing Toolbar, and it just allows you to capture some traditional shapes, rectangles, ovals, circles, that sort of thing. And I'm going to capture circle for the greater part of the Gigafactory. Okay, so let's start editing, and then I'm going to digitize a circle. So I just select the circle option, click up here somewhere, drag a big old circle that covers the Gigafactory, and then right click to finish. I'll give it an ID and a name, and then save that. And the next step is I want to go back into Google Earth Pro and just digitize a couple other features. I want to digitize the highway, the surrounding forests, as well as the open land, or the land that's been modified by development. So I want to export this back to QGIS, back to Google Earth Pro. So I want to set that up as a KML, and then I'll just put it in my same old folder. I'm just going to call it gigapoly for gigapolygon, and everything else should be fine. Let's say OK. I don't need these anymore. I'm going to remove them both, and let's go back into Google Earth Pro. And then to the file, open, and I just need to make sure I go to that folder, Giga Data Poly. There we go. So now that'll give me the extent of that footprint. So I know that everything inside the circle will be part of that Gigafactory footprint. So what I'm going to do now is draw a few more polygons to capture the highway, for instance, as well as this development here. And I don't think I'll go too much further than that, just to try and keep this as short as possible. So let's start off by capturing a new polygon. We'll call it highway. I'm going to drag this off onto my second screen, and then zoom in and then capture everything that is the highway here. And maybe what I can do is just show you what I'm doing here, change the style and color so that I can see what's happening underneath the feature that I'm capturing. So I'm changing the color to red and the opacity to 50, and that'll make the layer transparent and allow me to see what's happening underneath it. Just make sure I stay opening or an editing session, and then capture everything that isn't part of the forest. This is the off ramp, kind of goes this way. Okay, so I'm satisfied that that has captured the majority of the open land for that highway, and then I'll capture one more for this portion, which is, I'm calling it open land, but essentially it's everything that isn't part of the forest. So it's going to be, just make sure I start editing again, drag it off to my second screen, and then capture everything that is part of this open square here. It's not really a square, but you know what I mean. And I just need to capture to the extent of the circle, because everything that is outside of the circle is going to be excluded from my final layer in any event. So I can say OK. And I now have captured the highway, the open land that isn't trees or plantation, and then this section. Now, strictly speaking, I should also capture this road, but to try and speed things up, I'm going to ignore that and just use these 3 layers as my land use layers. So what I'm going to do is create a new folder in Google Earth. I'll call it land use. I'll say OK, and then I will drag those 2 new polygons into that folder, and then export that folder as a KML. There we go. Now we can go back into QGIS. Okay, so let's refresh this. And then we've got our new layer. Drag that in, and there's our 2 new polygons. And we've added those 2. We can also add that circle that we used, and we are now going to union all of these layers together to get a final layer which combines both of them, or all 3 of them. So geoprocessing, union, and our input layer can be, we've got poly and land use. That's fine. We run that to create a temporary layer. Close. There we go. So what we can do now is we can open up that union layer. We can just tidy it up a bit. Delete all of these fields that we don't need. And then I'm going to select those shapes, and those 2 shapes will be, let's call them open, then everything else will be forest. And then everything that sits outside of our project, or outside of our project area, we're going to delete. So those are gone now. I can remove this too. Let's save this union layer. And then at the moment we've got, it's a bit messy over here, so what I'm going to do is I'm going to dissolve those into one layer so that we've got one final land use layer. So we'll just use the geometry, the geoprocessing tools, dissolve union, and we're dissolving using the name field. And we can create a temporary one just to make sure that it does what we expect it to. There we go, we're happy with that. So that dissolved layer is the land use layer. So I'm going to make that a permanent layer because it is displaying what I expect to see. Actually, before I do that, what I'm going to rather do is I'm going to export it, and I'm going to choose the new EPSG of 3857. It needs to be a shapefile, and the file name can be land use. Okay, so I've changed the coordinate reference system to something that is in meters, so I can calculate area in meters and not decimal degrees. So we click OK, and we've got a new layer. And we can delete everything else. Open up that attribute table just to make sure it's got the information we need. There it is. And what we can then do is just color up on those attributes using the layer styling panel. I'm going to categorize using the name, classify, and there we go. And what we can do is just make that slightly transparent, apply that, close it, and then if we turn on the Google satellite imagery again, just remove this layer, and we should be able to see through it. And we'll now be able to use the different land use type to create that random point generated file, which will represent our trees. Okay, so our goal is essentially to determine how many trees are being affected by the footprint of the building. So if we have a footprint of a certain size, how many trees need to be removed? Now I don't have a point file for the trees, so I have to create one. And strictly speaking, well, I'm never going to be able to capture all of these trees, and you wouldn't really want to anyway. So we are going to use an algorithm which creates random points for all of the trees in a selected area. And I'm just having a look online, notice that the density for plantations like this is 2,300 trees per hectare. And in order to create the random point file, we need to know how many trees are going to be in our selected area. So let's calculate the area for these sections of our land use, and then times that or multiply the area in hectares by the number of trees per hectare to come up with a total number of trees, and then we'll run that random point generator. So let's open up the attribute table, and what we'll do is create a new field using the field calculator. We'll call it trees, and the equation we're going to use is first to calculate the area. So let's open brackets. We'll go $area divided by 10,000. So $area calculates the area in meters squared, and we want to divide it by 10,000 to get that to hectares. And then that is going to be the area in hectares. Now we need to calculate the number of trees per hectare. So we're going to multiply that by 2,300 and then click OK. And there we go. So based on that quick calculation and using that density, which is an average density, it might not be the correct one for these different pockets. You can see that there are actually sections of this plantation that are slightly less and more dense than each other. So let's just assume that the density is uniform throughout this study area, and we'll go with that. So it looks like for the forested areas there are 720,183 trees. So let's now apply the Gigafactory footprint and see how many trees need to be removed from this area. Right, so the next step is to create those trees. And you can type in the little search bar at the bottom left hand corner of your screen, random, to return the algorithms. And actually before I do that, I want to select the area to calculate for, and it's going to be random points inside polygons. And we're going to use the land use layer for selected features only. We're counting the number of points, and it was 720,000. Actually, let's go double check that. Close that. Just double check exactly how many trees there were in this area using my identify features. And what you can do is you can right click on a value and copy that attribute value to your clipboard. We'll deselect that. And now we've got that on our clipboard, we can go and run that equation again, or that algorithm again. So selected areas, points count. This is going to be the point count. So it's, yeah, that's correct, point count. So this is the number of points, that many trees. And then there's an option to set the distance between trees. And just to make it uniform, we'll make it 1.8 meters, which is what these plantations generally like to, well, the distance they like to have between their trees. And we'll create a random layer to see what this generates. Okay, there we go. So it looks like it's finished, and we've got our random points. And that looks like what I expect to see. So I'm going to convert this into a shapefile. I'm going to select Make Permanent, and I'll just put it in that data folder that I have. I'll just call it Trees. Okay, the next step is I'll just color these up so that they are easier to view. What color should we make them? Dark green or yellow? Maybe orange. Okay, so all our trees are colored orange. It's a mass of points, so at this scale it looks like a solid mass of points. But if we zoom in, we can see there are unique number or unique features there. Just zoom out a little. Maybe change that color. That color is not working for me there. I think blue works best. Okay, there we go. Now we can actually start capturing the footprint and then create our graphic model. Okay, so for now I'm not interested in the trees anymore or the land use, but I want to capture the extent of the study area boundary and then also the building footprints. So let's create two new shape files. I'll call the one extent, and it'll have the same coordinate reference system as the project. We'll give it one field and then another one which I will call footprint. We'll just change the colors for these so that they are easy to edit. And let's start with the extent. Okay, so now we are assuming that OpenStreetMapping have captured the actual extent accurately. But you can use the same method to capture your site. So let's just assume that this is accurate. Okay, so not 100%, but it's pretty close. And we'll do the same thing for the footprints. Now for the footprints, I'll just capture the what looks like the building footprint. So I'll capture this one and that one. Okay, we'll call that one Giga for the Gigafactory. I don't know what this one is, but We'll just give it a random name. Outer building. Let's just call it outer. Okay, there we go. So now we have two polygon layers for the features for the Gigafactory. So that is all we need for our layers. So we'll now be able to use these various layers to demonstrate how the graphic modeler works, or the graphical modeler works in QGIS, and that is the next video we'll create. So that is part 2 of this 2-part video series, and yeah, follow on with that and I'll show you how that graphical modeler works. It's a pretty nifty tool.